At the bottom of the Mediterranean, inside the wreck of an ancient cargo ship, divers recovered a corroded lump of bronze that looked almost worthless. It had no face, no clear markings, and no obvious purpose. Then the bronze was examined more closely. Inside were gear teeth, not a few crude wheels, a tightly packed system of precision gears, scales, pointers, and inscriptions designed to calculate the movement of the sky. The object had been built more than 2,000 years ago, and nothing else approaching its known complexity would appear again for at least 1,000 years. Today it is called the Antikythera mechanism. It is often described as the first known analog computer, but that simple label hides the real mystery. The machine did not merely measure time. It predicted eclipses, tracked the moon, followed the sun, marked calendars and athletic festivals, and may have displayed the movements of the 5 planets known to the ancient Greeks. All of it was driven by turning a single handle. The question is not only how it worked, the question is where the knowledge needed to build it went. In the spring of 1900, Greek sponge divers took shelter from a storm near the small island of Antikythera, between the Peloponnese and Crete. While waiting for calmer weather, one diver descended and found a shipwreck lying roughly 40 to 50 meters below the surface. The site was filled with statues, pottery, glassware, jewelry, coins, and other cargo from the ancient Mediterranean world. Greek officials organized one of the earliest major underwater archaeological recoveries. Among the objects raised from the wreck was an unremarkable mass of corroded bronze and wood. Most people would have walked past it. But hidden inside it was something that should have changed the history of technology immediately. A gear wheel, then another, and behind them, fragments of Greek writing so small and damaged that much of it could not be read. If discoveries that force us to reconsider ancient technology are why you are here, subscribe and turn on notifications, because the first clue inside this machine was not found on its surface. It was found inside metal that no human eye had seen for 2,000 years. The wreck itself dates to the 1st century BC. The mechanism appears to have been constructed around the end of the 2nd century BC, making it older than the ship that carried it. Who made it is unknown. Where it was built is still debated. Why it was aboard the ship remains uncertain. It may have been a valuable scientific instrument being transported to a wealthy owner. It may have belonged to a school, philosopher, astronomer, or collector. It may even have been old when the ship sank. What survived was incomplete. The mechanism is now divided into 82 fragments. Only about 1/3 of the original device remains. 30 bronze gears survive in corroded form, while much of the front display and many internal parts are gone. That should have made reconstruction impossible. Instead, the broken pieces became a puzzle. Researchers began by examining the visible gears. Their teeth were triangular and carefully spaced. The wheels were arranged to transfer motion through mathematical ratios. Turning one part caused others to rotate at different speeds. This was not decoration. It was calculation made physical. The back of the mechanism carried 2 large spiral dials. One tracked a 19-year calendar cycle. 19 solar years are close to 235 lunar months. By using that relationship, the device could help keep lunar months aligned with the solar year. Another dial followed a cycle of 223 lunar months, known as the Saros cycle. That number was the key to predicting eclipses. After 223 lunar months, the geometry of the Sun, Earth, and Moon returns to a similar arrangement. Eclipses can repeat in a recognizable pattern. Ancient Babylonian astronomers had studied such cycles centuries earlier. The builders of the Antikythera mechanism took astronomical knowledge and turned it into gears. On the eclipse dial, small markings indicated months in which a lunar or solar eclipse might occur. Inscriptions could describe whether it was expected to be solar or lunar, its approximate time, and characteristics associated with its appearance. The machine was not seeing the future. It was using recorded cycles to calculate when the sky was likely to repeat itself. But to anyone watching the pointer move toward an eclipse years before it happened, the distinction may have felt very small. Here is where it gets stranger. The mechanism did not treat the moon as if it moved at one constant speed. From Earth, the moon appears to speed up and slow down during its orbit. Reproducing that irregular motion mechanically required more than a simple pair of wheels. The surviving gears include a pin and slot system that changed the moon pointer's speed during each rotation. In other words, the machine reproduced a changing movement in the heavens, using bronze components, small enough to fit inside a portable case. It did not simply show where the moon should be. It imitated how the moon appeared to move. The front also included a rotating display showing the lunar phase. One side was light and the other dark. As the mechanism turned, the sphere displayed the changing shape of the moon. New moon, half moon, full moon. Then darkness again. The heavens had been compressed into a box. For decades, researchers understood parts of the mechanism, but could not see deeply enough into the corroded fragments. Then modern imaging changed everything. In 2005, researchers used microfocus X-ray computed tomography and advanced surface imaging to examine all 82 surviving fragments. The X-rays passed through layers of corrosion and revealed gear structures hidden inside the bronze. They also exposed inscriptions that had not been read for more than 2,000 years. The machine had been carrying its own explanation. Tiny Greek characters had once covered plates and surfaces around the mechanism. They described astronomical cycles, displays, calendar information, and the behavior of the heavens. This was not a mysterious object with no context. It had something close to an instruction manual. The inscriptions showed that the front displayed the sun, the moon, and the 5 planets visible without a telescope: Mercury, Venus, Mars, Jupiter, and Saturn. That discovery created a new problem. Most of the front gearing had vanished. Researchers knew what the machine was supposed to display, but not exactly how its maker had fitted all those motions into the surviving space. In 2021, a team at University College London proposed a new reconstruction of the front system. Their model used the surviving evidence, gear counts, inscriptions, and ancient Greek astronomical theories to produce a mechanical display of the cosmos. At the center was Earth, according to the astronomical model of the period. Around it moved indicators for the moon, sun, and planets. The planets did not simply circle at constant speed. From Earth, they sometimes appear to slow, stop, and move backward against the stars. This is called retrograde motion. The proposed mechanism recreated these complex cycles through carefully arranged gear trains. One turn of the handle could move an entire mechanical universe, but the researchers were careful. Only a third of the original survives. The 2021 design matches much of the surviving evidence, but it cannot be claimed as a perfect replica of the lost machine. That uncertainty matters. The Antikythera mechanism is not fully solved. Different reconstructions still disagree over parts of its design, especially the missing front. Yet the surviving evidence is already extraordinary. This was a computational instrument for mathematical astronomy. It combined Babylonian numerical cycles with Greek geometry and mechanical engineering. It tracked calendars. It predicted eclipse possibilities. It represented the moon's changing speed and phase. It marked cycles connected with major athletic games, and it may have displayed the positions and cycles of the known planets. No batteries, no electricity, no hidden power source, only bronze, mathematics, observation, and human hands. Now, does this prove the ancient Greeks had modern computers? No. The mechanism could not think, store digital information, or make decisions. Calling it a computer describes its ability to perform calculations mechanically, not an equivalence with modern electronics. Does it prove there was an industrial world of machines that archaeology has somehow concealed? No. Only one mechanism of this complexity has survived, and there is no evidence for factories producing them on a modern scale. But that explanation has its own problem. Objects this sophisticated do not usually appear from nothing. The maker needed astronomical tables, mathematical models, skilled bronze workers, precision tools, and experience designing gear trains. There were probably earlier devices, failed experiments, teaching models, or related instruments. Ancient writers described mechanical models of the heavens. Some associated such devices with famous thinkers and workshops, but no surviving text tells us who designed the Antikythera mechanism, and no second complete machine has been found. The device is an endpoint without a visible beginning, and after it disappeared beneath the sea, its tradition seems to vanish with it. Later civilizations built complex clocks and astronomical instruments, but the exact pathway from ancient Greek geared models to medieval machinery remains incomplete. Knowledge can disappear without a conspiracy. A workshop can close. A specialist can die. Bronze can be melted and reused. Wooden cases can rot. Wars can destroy libraries. A device made for a small, educated elite may never be copied widely enough to survive. The mechanism may look unique, because almost everything related to it was lost. That is the most grounded explanation. It is also the most unsettling, because it means technological knowledge does not always move forward. Sometimes it becomes concentrated in a few hands. Sometimes it survives inside one workshop, one school, or one chain of teachers. And when that chain breaks, an entire way of building can vanish. The sea preserved what history erased. Today, the fragments remain in the National Archaeological Museum in Athens. They no longer resemble a working machine. They look like broken, green-brown pieces of mineralized bronze. Yet inside those fragments are the remains of a moving cosmos. A moon that changed speed, a sphere that changed phase, a pointer that moved toward eclipses before they arrived. Planetary cycles translated into teeth, pins, slots, and rotating rings. The ancient Greeks did not build a machine from the future. They built one from knowledge that the future failed to preserve. And somewhere in the missing 2/3 may be the final answer to how they did it. The ship sank. The workshop disappeared. The maker's name was lost. But beneath the corrosion, the gears are still waiting, and the next investigation is waiting on screen now.